This video is on an FRQ that we've already answered Part A and Part B for. This is the third in a sequence of 3 for answering FRQ number 3. If you haven't looked at the first 2 parts, be sure to subscribe to the channel. And when you do so, go to the playlist where I have AP18 FRQ test preparation, and you'll see a whole series of videos that will give you some important tips and methods for doing well on the AP Chemistry FRQ questions. Parts A and B for FRQ 3 here were worth 1, 2, 3, 4, 5, 6, 7 points, a hefty number of points. You get that many points consistently on the FRQs, 70%, and you're shooting for a 4 or most likely even a 5. But let's try and get the last 3 points of this 10-point FRQ to get that elusive perfect score. So on to Part C. The rate law for the reverse reaction is rate is equal to reverse K times the unpronounceable ion and hydrofluoric acid. Now, I've rewritten this reaction to show what's happening because I know the original reaction was this. Here we had the original reaction with the tetraborofluorate and the water, and I just flipped things around because I wanted to have a good view of what's happening as I answer this question. Now, the first question is one of these where they've got a student claim. A student claims that the initial rate of the reverse reaction is 0. Okay, here's a reverse reaction, and they're claiming that the initial rate, that means when you're starting at time 0. Do you agree or disagree with this claim and justify your answer in terms of the rate law for the reverse reaction? They've already given you the reverse reaction, and here it is. You can write it out. Rate is equal to the Kr times the concentration of our reactants, which are now BF3OH and HF. Now, they wanted to know what the initial rate is. Well, that's at time 0 that they've given us the HF concentration, and guess what? It's 0 initially. That's what you'd expect. That's where we have our graph, and we're starting off with no HF. Therefore, using this, we're going to have to agree, because if you've got a 0 multiplying this thing, then you're going to have 0 as our rate. We didn't have any HF. 0 times anything is going to give you 0. Now, again, we want to go through this question that we decided what the answer was. Do we agree or disagree? We answered agree is all you have to say, and just give some sort of a sentence saying, 0 times everything is 0. Justification doesn't require much, just one sentence. So we've got that point. Up on to D. Here we are at D, and remember I've said that very often the last couple of points on a FRQ are sometimes easier than you'd expect. Let's read it and see if this is true here. At equilibrium, the forward and reverse reaction rates are equal. Yes, that's true. That's always true for all equilibria. Calculate the value of the rate constant for the reverse reaction. We have our reverse reaction, and here it is, where we've got the BF3OH and the HF as our reactants. Before, they told us the HF concentration was 0.0174. Well, therefore, we know that this unpronounceable ion had to have the same concentration because they were both made by our initial tetrafluoroborate and water. So if we rewrite that equation where we have rate for the reverse reaction that they gave us is equal to the concentration of the HF, which we know, and therefore the unpronounceable ion is the same, we can just write that out this way. So let's pull out our calculator. We've got the setup, and look, our previous answer was 1.2 times 10 to the negative 4. Don't clear out your calculator when you're doing a problem, because previous answers will come in handy. So all I'm going to have to do is divide by our 0.0174, the concentration of the hydrofluoric acid, and I'm not going to type it in again. I'll just square it. And since I have the rate equal to the forward rate, I've got the concentrations of the two substances at equilibrium. Enter. Now, is that the right answer? Let's find out. There's our calculation and 0.0396. Now, don't forget the unit. This is going to be critical because this reaction is a second order reaction where we have both of these, and this constant is going to have to be, since we're calculating it, per molar per minute, because these values have to multiply out to make a rate of molar per minute. So if we have a constant that is per molar per minute, that 1 per molar cancels out one of these m's, and we have left molar per minute. The answer, 0.396, is good, but without the unit, you'd lose the point. The point is earned for the appropriate numerical substitutions in the rate. You got a point for putting these numbers in, and then you got a point for the right answer with the correct units. So that's how it's graded. We just got 2 more check marks, and we've got our total of 10 points. Only 1 out of 100,000 students gets a perfect score on the AP exam.